In the last lecture, we built a small command line app that uses a module or a package that we downloaded using npm. In this lecture, we'll write our own module. So the goal here is to write a module that allows us to encrypt and decrypt text strings using the AES 256 encryption algorithm. The encode method must take in a string in the UTF-8 format and should return us an encrypted hex value. And the decode method should be able to take this encoded hex string and convert it back to UTF-8 human readable sentences. Therefore, before we write the module, let's take a quick glance at what AES 256 is and how it works. Now, critical data such as passwords, email addresses, and bank records such as account numbers, credit card numbers, transaction IDs, and other things cannot be stored as plain text. They have to be encrypted first. One of the strongest encryption algorithms or techniques is the Advanced Encryption System or AES. More specifically, the 256-bit version of the AES algorithm is considered to be very secure. To encrypt plain text data with the AES algorithm, you need the plain text string itself along with a key. The key is like a password or like a key used in a traditional lock and key device that you would use to secure your home or locker cabinets. So, plain text encrypted using a particular key can only be decrypted using the same key. In other words, a lock can only be opened by its own key. This means we would need to supply our AES algorithm with the same key when we have to decrypt data as the one we used when we encrypted the data in the first place. It is because of this reason that AES is known as a symmetrical algorithm. The length of the key used is 256 bits and hence the name of the algorithm as AES 256. You can go into more detail about the AES 256 algorithm by following the link given on this slide. So let's jump back into code and implement our module. The first thing I will do on the terminal is create a folder that will house our project. So I'll call it my module. And then inside this folder, I'll create a folder for the encryption module that we will create. I'm going to call this module as Enigma after the German rotor cipher machine from the World War era. Now use npm init inside the Enigma folder because we want to create a package.json because a module should be prepared like a package which can be published on npm. Though we are not going to publish our Enigma module on npm, we will nevertheless create our package.json file. So type npm init and press enter. And we'll just leave most of these things at defaults really. I'll just add a small description perhaps. Now inside the Enigma folder, create the module file itself. I'll save this as index.js because if you name your file as index.js, then you can just refer to its folder name when using the require statement and Node will automatically assume the presence of an index.js file inside the folder. Much like how web servers expect the presence of default HTML files like index.htm or index.html in the root of a folder housing a website. Also, the index.js is listed as the entry point or the main file in the package.json as well. This means that if you want the file to be something other than index.js, just put its file name in your package.json under the key called main, which is also known as the entry point when we use npm init to create the package.json file. So inside our index.js, we'll begin as usual by the use strict expression. And then we'll do something interesting. I'll type exports.hello and we'll set it to a function that accepts a user's name and returns the statement hello followed by the user's name. Okay, so what just happened here? The exports expression is a utility used by the module system to prepare a function to be made available to the outside world. To illustrate what this means, I'll create my app.js outside of the Enigma folder, and this will be the app where I want to use my Enigma module. Inside the app.js, I'll use a const identifier called Enigma, and I'll use my require statement which points to // and the Enigma folder. The / here means that the Enigma folder's path is relative to the app.js file. Note I'm just calling the module folder, and the module system will automatically get to the index.js file which contains the actual code for the Enigma module. So using a console.log statement, I'll call enigma.hello and we'll pass in the username Dave like so. Doing this, we'll call the hello function we wrote in our Enigma module, and it should print out hello Dave on the console. So let's first step out of the Enigma folder and we'll run our app.js. And sure enough, we've got hello Dave on the console. So congratulations, you've just written your very first working module. We can again use the exports keyword to bind another function called good morning, and this should return good morning followed by the user's name. And this also works as expected. So exports, as the name implies, exports out a function so that it could be used within other scripts once the file is brought in using the require statement. This brings us to module.exports, the actual object which is exported out of a module. When we use the exports keyword, we are essentially binding this function to the module.exports at the end. But exports by itself can be overridden if we use module.exports instead. By using module.exports, you can export the entire object containing properties and methods all at once. So let me remove the export functions, and instead we'll begin by typing out module.exports and we'll set it to a constructor function that returns our hello and good morning methods like so. If you try to run your app.js file, it'll throw an error because we'll first have to create a new instance of this constructor function back in the app. So first, let me, as a convention, refer to the Enigma module using an uppercase E, since it's now returning a constructor. And then in another identifier called eng, I'll instantiate the Enigma module by using the new keyword like so. We'll also replace references to Enigma with the eng identifier. And now it works as expected. Alright, let's get down to the actual functionality that we want to implement in this module. So let's remove the hello and good morning functions, and I'll replace them with two methods, an encode and a decode. Both these functions accept a string as their input. Now, modules can import other modules, and so in reality, your module is no different from a regular Node.js app, except that it exports its key interfaces out for others to use. So here, we are going to use Node's built-in crypto module for performing the actual encryption and decryption work. This module depends on OpenSSL, which is a library of various cryptography standards and algorithms. Now, you should know that any variables or identifiers declared like the crypto identifier here will be considered local to the module, and will not interfere with any variables or constants in your app. Now, since an encryption key string is also needed for performing the cipher task, we want to give the user the ability to set this when using the Enigma module. So essentially, when we instantiate the Enigma function, we want to pass in this key so that it is set for the duration of the availability of that instance. I'm going to set my key after the richest planet of all time, Magrathea. Back in the module, we'll accept this using a variable argument called key within the function like so. And we'll use this.key to set the value within the namespace here so that the key is accessible by both the encode and decode functions. And oh, I forgot the fat arrows here. There. Now, within the encode function, we'll create a variable called encoder, and we'll set this to access the create cipher method from the crypto module like so. When instantiating this, we'll also set the encryption standard to AES256CTR, and after a comma, we'll pass in our this.key variable, which will let us access the encryption key string, which the user assigns when instantiating the Enigma module. The CTR version of the AES256 that you see here is a highly performant and optimized version of the AES standard, and it accepts data as streams rather than the whole thing at once. Therefore, we will use the update method to stream in the string into our encoder instance, and we'll also set the incoming data encoding to UTF-8 because this is how we are receiving the data as simple UTF-8 strings. And we'll also set the resulting output to be in hex format. The update method simply allows streaming data to flow in and it outputs the resulting hex. So we'll simply return this hex to the calling app. Back in our app, we'll create a variable called encoded string within which we'll invoke our encode method, and we'll pass in the string don't panic. Let's console log this out to see what we get. When you run the app now, you can see a hex string which is the encrypted version of the string don't panic. The decode method is going to be an exact mirror of our encode method. Only this time we'll use the create decipher method instead of the create cipher. Also important to note that in the update method this time, the input encoding method will be hex and the output will be UTF-8. Back in the app.js, let's create another variable called decode string where we'll invoke the decode method and we'll pass in our encoded string using the encode string variable. Let's also output this on the console and see what we get. And there's a small typo in our code. It should be eng.encode and not end.decode. Now let's run our app again, and surely this time you can see our encode and decode functions performing well. Now just for fun, let's equip our Enigma module to generate QR codes as well. So we'll add our familiar QRGen method to our Enigma module like so. Only this time, it'll accept the data to encode into the QR code as a variable along with the reference to the file name to write the code to. We'll also require the QR image module like last time. So let's go back on the terminal and inside the Enigma modules directory. Now let me show you two things here. First up, if you want to query and see the latest version number of a module that you wish to download, then you can type npm view followed by the module name, which is QR image in our case, followed by version. This queries the npm registry and prints out version 3.1.0. Now, if you want to download a particular version, and npm hosts all versions in a module's lifecycle, simply type npm install module name @ followed by the version number, and we'll also use ~save to key in this module into our package.json's dependencies section. Now I'll get the QR image module and the FS module in like last time. And let's implement the functionality as we did before. The only difference here is that I'll return a true if both arguments to the QRGen method were supplied by the user, or false if that was not the case. Back in our app, we'll invoke the QRGen function like so. The reason I'm assigning this to a variable called QR is because the QRGen will return a true or a false. So using a simple ternary operator, we'll check to see if QR is true, and then we'll print a success message on the console, or we'll print a failure message like so. So when we run the app now, we get our QR code as well. So this is how you can write your own modules. Module.exports or exports can be used to export functions, objects, and even properties like arrays and variables. So give it a shot and try writing your own Node.js module.